Do you feel like school physics and maths are getting tougher and it's difficult to score marks? Are you struggling with the concepts of physics and maths, which should be rather simple? In this session, I am teaching two UK students of grade 7, and whether you are in grade 7, 8, 9, or 10, you can simply see how these simple concepts, when explained in a proper way, can make your learning super easy and fun for you. Hi, I am Chandan Kumar, and I am teaching physics and mathematics for NEET and JEE students from last 15 years. But today, I want to show you something even more important, that how if we start the journey not from 11th, but from 7th or 8th class, then the journey becomes rather fun and it's very simple. Watch how these complex topics can become super fun and easy if learned from early classes.
The topmost point of the wave basically are called crest, and the bottommost point is called trough. So, Deepika, what is the wavelength here? Distance from where to where will be called as a single wavelength. If you remember.
The beginning to the end. The beginning to like.
Yeah, so I'm asking distance from which point to which point we should call it as a wavelength. For example, these are the points. Let me mark them. A, B, C, and this is a D, and this is E. What do you think? Distance from which point to which point should be called as a single wavelength?
A to C.
A to C, very good. So one crest to consecutive next crest. The distance between two successive crests is called wavelength, lambda. It is denoted by lambda. And what about distance between B and D? What should it be called? Distance between B and D, two consecutive troughs. Yeah. Distance between B and D should also be called as wavelength. Isn't it, Deepak? This is also wavelength. You will say, okay, so distance between two consecutive crests or distance between two consecutive troughs, both are equal and both are called wavelengths. Right? Yes, Deepak. What is the distance between C and D? What is the distance between C and D?
Wavelength.
Wavelength, yes, very good. So wavelength we have understood. Wavelength is denoted by here lambda. Wavelength is basically measured as a distance. So it is basically a kind of length. The name itself is very much obvious. The wavelength, it is not a time. It is not a something velocity. It is a length. It is basically a distance. Okay. So wavelength we have understood. What is the time period now? We need to understand now something about the time period. Yes. What do you think? Deepak, anything related to time period, you know?
No, I don't really know. Oh wait.
Okay.
Is time period the time it takes for a wave or like something to produce a complete wave?
Yes, you are almost right. Deepak has just told that the time period is basically the total time taken for a source to generate one complete wave. So that's also right. And in other way, we can say the time period is the time taken by the wave to travel a distance equal to its wavelength. It is the time taken by the wave to travel a distance equal to its wavelength. That is called time period. Okay. Time period is what? The time taken. Please keep making notes.
Okay.
Yes, Deepika, this is very important. Please make notes because you are saying that I haven't learned this before. So only few things are there. Just by learning these few things, you will be able to solve such a type of sums very easily. Okay. It's not that 10, 20 things will come before solving the sums. Only, 4 to 5 things we need to know. And just based upon that, we can easily solve the sums of this chapter. Okay, Deepika? So the time taken by wave to travel a distance equal to its wavelength. Wavelength we have just understood. Wavelength is the distance between the two consecutive troughs or two consecutive crests. So that lambda, that wavelength, in whatever time it travels, that is called time period. So now the velocity. Now velocity. So what is velocity? Velocity is distance by time. It is ratio of distance traveled and time taken by the wave. And time taken by the wave. Yes, Deepak, are you writing? Hello, Deepak.
Yeah.
Yes, Deepika, you also keep writing. Make proper notes. Okay, Deepika, I can't hear you. Hello?
Yeah, I am.
Yes. So velocity understood? Velocity is very simple. It is the ratio of the distance traveled and the time taken by the wave. It is denoted by the same thing, v, as we already know. Velocity is v. So time period was denoted by capital T. Now can you tell me that what should be the relation between lambda, capital T and v? What should be the relation between these three? Hmm?
Wait, was it V? Wait, what was it?
V is equals to, v is the velocity, should be distance over time.
Okay.
Distance over time. Yes, Deepika, what is the distance traveled here in one time period? What distance the wave travels in one time period? Yes, Deepika?
Wavelength.
Wavelength. Yes, very good. In one time period, the distance traveled is wavelength. So I should write here lambda at the top. Yes or no? I
Yeah.
should write lambda. And at the bottom, what should I write?
Time period T.
Very good. That's correct. So at the bottom, in the denominator, I should write t, time period. So v is equals to lambda over t. That we need to do here basically. So this relation I'm putting in the box. Please write down and remember this. Directly we will use in the sums. T is equals to velocity basically, also called speed. So speed or velocity of the wave is distance traveled over time taken. So lambda over t. Please let me know if it written till here.
Yeah.
Okay, very good. Deepak, have you written till here?
Yeah.
Okay, very nice. Next is frequency. Its full name is linear frequency. Linear frequency. So how to find that and what is the basic definition of that? Basically, a linear frequency, it is the number of waves a source produces per unit time, or in 1 second, we can say in 1 second. It is the number of waves a source produces in 1 second. So, or in other way, we can say it is the number of wavelengths a wave travel in 1 second. That is another definition of the same linear frequency. It is the number of wavelengths a wave travels per unit time. Per unit time, or we can say in 1 second. So you will say, okay, but how to denote the frequency? So frequency basically is denoted by small f. and it is reciprocal of time period. F is equals to 1 over T. You will say how? Because the time period was basically the time taken to travel one wavelength, and this is basically the number of wavelengths traveled in one time period, or sorry, in one second per unit time. So it is basically the reverse of that. That's why time period and frequency are reciprocal of each other. So please remember, this is very important point. Frequency is always 1 by T. Okay.
Yeah.
Yeah. So have you written, Deepak, till here?
I'm writing it down.
Yeah. Okay. Please write down.
Am I finished?
Deepika, finished till here?
Yeah.
Yes, Deepika. What was the relation between velocity, lambda, and t, which we did earlier?
Velocity equals lambda over t.
Very good. This was one relation. What should be relation? What should be the relation if we want to find lambda in terms of velocity?
Velocity times time.
Very good. What should be the relation if we want to find velocity in terms of lambda without using
V
time, but
without
with using frequency? What should be the relation if we don't use time but use frequency
wait
instead?
to find velocity. It's lambda times frequency.
Very good, because 1 by time period we have just seen here. You can see we have just seen here 1 by time period is basically frequency. So we should write 1 over t as frequency. So v equals to lambda into f. So please write down all the equations. अभी नहीं, गाड़ी वाला चाहिए इसमें, मेरे को नहीं पता, अभी मैं बाद में लाऊंगा, अभी क्लास में. So v is equals to lambda over t, lambda is equals to v into t, and v is equals to lambda into f. What should be the relation, Deepika, if we want to find, suppose we want to find frequency. So suppose we want to find frequency, then what should be the relation? Frequency equal to how much in terms of velocity? Yes, Deepika. Frequency in terms of velocity. You can just tell from this equation. You can just tell using this. Yeah, very nice. Frequency is basically v over lambda. All these relations have you written?
Yeah.
Okay, very good. Deepak, have you written?
Yeah.
Okay, let's try applying this in sums. So the question is, first sum is, a wave has a frequency of 50 hertz and wavelength of 0.02 meters. Calculates its speed. Let me write it down. A wave has a frequency of 50 hertz and wavelength of 0.02 meters. Calculate its speed. Yeah. How will you do that?
The answer is the speed. Is the answer.
क्या कर रहे हैं?
Wait, a wave has a frequency
इधर
and a
तुम बनाए
wavelength of calculate speed. Would it be frequency over wavelength?
frequency is given 50 hertz. Wavelength is
I mean,
given
would
0.02 meters.
would the speed be frequency over wavelength?
Yeah. Speed is equals to frequency over wavelength, you are saying. This. But this we haven't, what we have just did. This is not the formula what we did it.
It's frequency times wavelength.
Yeah.
My
So
bad.
speed is
The
equals to
answer
wavelength and frequency. We need to multiply them. Yes,
is
tell me
1
the
half.
answer.
1. I don't have a calculator. It should be 1 though.
Yeah. Deepika, you have done also?
Yeah. I got 1.
Deepak has got 1 as the answer. How much you got?
1.
1 meter per second. Understood? The next one, I'm giving you the next question. The next question is, a sound wave has a frequency. A sound wave has frequency of 200 hertz. 200 hertz. And the wavelength? No, so this should be, I should give you 200 hertz is the frequency. And speed as 3 meter per second. Then find its wavelength. Yes, we need to find the wavelength now. Please calculate fast.
Is the answer 66.6? This will do frequency over speed.
Wavelength is equals to
600. Isn't it 600?
Oh wait, my bad, it's 600 you times it.
yes, Deepika, how much you got?
600.
Yes, because wavelength is basically speed times frequency. Sorry, wait. No, it's not speed times frequency. Speed divided by frequency. Speed divided by frequency. Yes or no? The formula what we have written. Which formula we have done?
Wasn't
Let
it
me.
frequency divided by
This formula, isn't it? Frequency is v by lambda. But what we need to find here? Lambda.
wavelength?
Yeah, so lambda will be how much from here? V by f, yes or no? Lambda will go there, f should come here, yes or no?
Yeah.
So lambda basically will become velocity by frequency. So this should be the formula. So velocity is 3, frequency is 200. So the answer should be exactly different from whatever both of you told. Deepak told frequency by velocity, 200 by 3 he did, which is just the reciprocal of the correct answer. Yes or no? Deepak, understood?
Yeah.
And Deepika, what you did is you multiplied velocity and frequency. We can't, like, there is no formula for velocity into frequency is something. There is product of velocity and frequency gives nothing basically. So the answer should be how much? 0.0015 I think this is answer or what? Yeah, no, 0.015 meter. This is the wavelength. Yes, understood? Okay, very good. So this time give the correct answer. Have you written this solution, both of you?
Yeah.
Yeah, okay. So this time give the correct answer. I'm giving you the next one based upon this concept. Okay, so a light wave, earlier one was sound wave, this is light wave. But any wave is a wave basically. Light wave has wavelength of 600 nanometers. 600 nanometers. Okay, it is wavelength of 600 nanometers and speed of 3 into 10 raised to the power 8 meter per second. We need to find its frequency. Yes, please give both of you correct answer. Yes. Deepak, what is nanometer means?
Pardon?
Nanometer means what?
It's like I believe it's 1/4, and it's like 1 in 1,000 of 1 meter.
1 in 1000
Essentially,
is called millimeter.
or then it's 1 in 10,000.
No, 1 in 10 lakhs basically would be a micrometer. Nanometer is basically 1 in 10 raised to the power 9. 1 over 10 raised to the power 9. That is called nanometer. So basically, nanometer means this many meters. 1 nanometer should be equal to these many meters. Basically 10 raised to the power minus 9 meters. So what you should do? You should write lambda is equals to 600 into 10 raised to the power minus 9 meters. You will say, is it necessary to convert in meters? Then I will say yes, because without converting in meter, because the speed is in meter per second, not nanometer per second. Speed is in meter per second. That's why the unit has to be in meters for wavelength also. Then only the answer will come out in second, or frequency will come out in hertz. Hertz is basically second inverse, 1 over time period. So that's why it is a unit of frequency. So you should write lambda is equal to 600 into 10 to the power minus 9. Now tell me the answer. Deepika, are you understanding this? How I did 600 into 10 to
Yeah.
the power minus 9? I converted nanometer into meter. Yes.
Yeah.
Please calculate. Which formula you are using? Deepika, give the formula first. Frequency is what?
F equals V over lambda.
Very good. Very nice. F is equals to V over lambda. So now you can calculate.
Is it 5 times 10 to the power 14?
Very good. That's correct. How much you got, Deepak?
I got 5 times 10 to the power 14.
Very nice. Both of you are correct. So basically we have to do the same thing here. Velocity, this frequency is v over lambda. V was given as 3 into 10 power 8, and lambda was how much? Lambda was 600 nanometers, so 600 into 10 to the power minus 9. So this power can go up, isn't it? If this power goes up, then before going up, it can do one thing. These two zeros are there, so 10 to the power 2 is there basically. So that should be balanced with this 10 to the power minus 9, and 10 to the power 2 is multiplied, so 10 to the power minus 7. So 3 by 6 becomes 0.5 because 1 by 2 after cancelling. So 1 by 2 is 0.5, and this 8 is already there, and this negative 7 is going up, so it will become again positive. So power gets added. So 0.5 into 10 to the power 15, and if you want to write it like 5, so one of the powers should be taken as the multiplication. We should write 10 into 10 to the power 14 basically. So 10 into 0.5 becomes 5. So 5 into 10 to the power 14 is the answer. Per second is called hertz, as I told you. Per second means hertz. So this is the frequency. Both of you did correct. So now let's give the next variety, because these type of questions you are able to do easily. The next variety is your tuning fork vibrates at 512 hertz. Please concentrate. 512 hertz is what? What is given this? This is what? Wavelength? Speed? What is this? Yes, Deepak, what is given? 512 is what?
Is the velocity?
No. Velocity is in meter per second. You have to see the unit.
It's the frequency.
Frequency. Very good. So now we are asking how many vibrations does it complete? Vibrations means number of waves, you can say. How many number of waves does it complete? In 2 seconds. You will say, okay, so the time is given here. Yeah, time is given. So the number of wavelengths basically we need to find. You will say, sir, but the frequency itself is the number of wavelengths in 1 second. You remember the formula? The definition which I told? What was the definition of frequency? Deepika, what was the definition? Yes, Deepika? Have you written the definition? Deepika, did you write the definition which I wrote earlier?
I was on mute. It's the number of waves a source produces in 1 second.
Very good. So number of waves it produces in 1 second, that is 512 hertz. Basically, that is frequency. It's given. But now they're asking us that how many waves, how many vibrations means how many waves does it complete in 2 seconds? So what will you say? You will say, sir, 512 in 1 second. So we should multiply it by 2 to get how many waves in 2 seconds. Yes or no?
Yeah.
So what is the answer then?
1024.
Yes. Understood, Deepak?
Yeah.
Deepak? Because it is direct from the definition. I told the number of wavelengths in 1 second, that is called frequency. So here they're asking how many vibrations does it complete in 2 seconds. So basically just we have to multiply by 2, because in 1 second it is 512 hertz. So in 2 seconds it should be 1024 hertz or 1024 vibrations, we can just say. Right? Now, this should be the homework for you. Please write it down. You can complete it and You can tell me in the next class, or you can
Okay.
send me on the WhatsApp also if it is done. A mosquito beats its wings at 600 hertz. Deepika, what is given? What is given this?
The
600 is what?
the velocity.
Velocity. 600 hertz.
Oh,
You
no,
please see the unit. Hmm? Frequency, isn't
the
it?
frequency.
Hertz means frequency. Hertz is the unit of frequency. So the question is, the mosquito beats its wings at 600 hertz, like it is flapping the wings. So how many times does it flap in 4 seconds? So this is one of the homework which you need to do. And then you can do one more question. There's, I should write, yeah, a wave takes 0.25 seconds to complete one cycle. What is its frequency? Question is, we need to find the frequency. A wave takes 0.5 seconds to complete one cycle, or basically one wavelength. So what is this 0.25? Can you please tell?
Time.
Time. What time? You will say it is time period. Time period is the time taken to complete one wavelength. Yes or no?
Yeah.
So that's time period basically is given and frequency is asked. So you can calculate both of them in the homework, and then we can see that in the next class. Otherwise, you can send me on the WhatsApp also. So see you in the next class. Have you understood everything, Deepika?
Yes.
Deepak, everything
Yeah.
is fine?
Yeah.
So we are closing here. See you in the next class then. Okay.
See you.
Have a
Yeah.
nice day.
Bye.
Bye.
I hope this demo showed you how learning physics and maths can be simple and fun, no matter in which class you are in. If you are in grade 8, 9, 10 and want to build the strong basics, strong foundation, let's learn together. By checking the description below, you can have the link through which you can book one-to-one session. Let's make maths and science a fun and easy together. See you in the class.